In this video, our forecast will be based on the Lagrange multipliers. How then do we deal with Lagrange multipliers? Let us look at the following example. Let me say now we want to find the maximum and the minimum values of 4xy, where 4xy is subject to the following constraint. This is our constraint, it's very important. And then we can call it this function f of a function f. And then this is 4xy. And then the constraint, let us call it g. So this is g, is a function x and y. And then our constraint will be x squared plus 2y squared. And then the constant on the right, always take it to the left. Then it means it's a -1. Then when we want to deal with Lagrange multipliers, it means we have to form a system of equations with 3 variables. So if we have 3 variables, then it means we'll have to form a system of equations with 4 variables. So for now we have 2 variables. It means the system of equation which we are going to form, it must have 3 variables. So we'll have the following system: x, y, and the third variable, let us call it lambda. So this equation is nothing but the equation of f of x minus lambda multiplied by the constraint. And then now we can replace f of xy with this equation. Then this is xy z minus the constraint multiplied by minus lambda multiplied by the constraint. Then this is our constraint. So it means we'll have x squared plus 2y squared minus 1, like that. Then we have the following equation that we are going to use. F sub x is given by lambda g sub x. And then we also have the following: f sub y is given by lambda g sub y. And then these two equations will help us finding the points. So f sub x is simply the derivative of f with respect to x. So this is our equation. Then we have to differentiate this equation with respect to x. Then when differentiate with respect to x, it means we will have 4y on the left, and then on the right we have lambda. G of x is our constraint. Then we are going to differentiate our constraint with respect to x. Then when we differentiate the constraint with respect to x, we get 2x. This is a constant, then it will give us 0. So it means we get 4y equals to 2x lambda. Then out of this, you can make x, y, or lambda the subject of the formula. But for now, let me make lambda the subject of the formula, and then I will divide by 2x both sides. So I will have 4y over 2x. 4y over 2x is nothing but 2y over x. Then this is the first value, the first equation of lambda we get. And then for this one, f sub y, this is the derivative of the function f with respect to y. Then with respect to y, it means on the left I will have 4x, because when I differentiate this with respect to y, then I will keep 4x as neutral. I differentiate y. Derivative of y is a 1, as you know. Then lambda g sub y is found from the constraint. Then we differentiate the constraint with respect to y. Then this is a constant, is a 0. This is also a constant, we get a 0, and then we differentiate this part. Then it means we'll have 4y. And then this can be written in this form: 4y lambda. So since this side we made lambda the subject, even here let us make lambda the subject of the formula. Then now lambda is nothing but 4x over 4y. You check 4 can cancel 4, and then finally we get x over y. Then now we have two equations. This is equation 1, this is equation 2. Lambda, lambda, and then we can equate equation 1 and equation 2. And if we say equation 1 is equal to equation 2, because we have lambda equals to 2y over 2x, over x and x over y, then it means we'll get 2y over x is equals to x over y. Then from now on, you can cross multiply. Then when you multiply y this side and you multiply x this side, and then on the left we'll get 2y. Y multiplied by y is nothing but y squared. X times x will give us x squared. Now let us look at this. This equation which we get here, we can relate it with our constraint. When we check, our constraint is x squared plus 2y squared equal to 1. But we have the following: 2y squared is equals to x squared. Then it means now where there's x squared, we can write 2y squared. So into our constraint. Then let us have our constraint x squared plus 2y squared equals to 1. So we're going to sub this equation into this constraint here. When we replace y with x squared, or x squared with y, then it means where there is x squared this time around, we must have the 2y squared. So it means this is 2y squared plus 2y squared equal to 1. 2y squared plus 2y squared is a 4y squared. Now we have 4y squared equal to 1 like that. And then we can divide by 4 both sides. Then on the left we'll have y squared, then on the right we'll have 1 over 4. And finally we can simply take the square root both sides. It means the value of y is nothing but plus or minus 1 over root 2. Not 1 over root 2, 1 over 2, because the square root of 4 is 2. So this is plus or minus 1 over 2. This is the value of y which we have for now. So it means if y is plus or minus half, we can find an equation that when we substitute the value of y, then we can find either the value of x or lambda. So let us try to look for one equation that will help us at this moment. We have which equation can we use for now to find x? Which equation that we can use to find the value of x? Alright, when we check this one for now will take us long because we will have two unknowns. Also this one will have two unknowns. Okay, but let us look at our constraint. So if we know the value of y, it means from the constraint we can find the value of x. Then it means we are going to sub y equals to plus or minus half into the constraint. By doing so let us first use the value of y as positive. So if y is positive, since we have the square here, whether it's positive or negative, then it will result in the same value. So I'm going to use the following: x squared plus 2. Where there is y, we can put plus or minus half squared equals to 1. And then now we want to find the value of x squared, and then this is x squared plus 2. 1 squared is nothing but a 1. Then 2 to the power 2 is a 4. It's equal to a 1 like that. Then we have x squared plus 2 multiply 1 over 4 is nothing but 2 over 4 equal to 1. Then x squared plus 2 over 4 is 1 over 2 equals to 1. Then we want to find the value of x. Then we can take 1 over 2 from the left to the right. Then we have 1 minus 1 over 2. 1 minus 1 over 2 is nothing but positive 1 over 2. Then we take the square root both sides. Then we have the value of x as plus or minus. The square root of 1 is a 1. The square root of 2 is a 2. And then we can rationalize this as we multiply by the square root of 2 over 2. It means we'll have root 2 over 2 as the values of x. It means now x can be positive or minus root 2 over 2. Then out of this information, we have already found the values of x and y. Then we also have to find lambda using these points. And then now let me say if x is equal to positive root 2 over 2 and y is equal to positive half. Let me use positive half. I want to find the value of lambda, and then I can use any of the equation that contain the variable lambda. Let me use this one for now. So we use equation 2. Lambda will be equals to x. So this is x root 2 over 2. We divide it by y. Y is half. So we can clearly see that out of this, x is not lambda is nothing but root 2 is positive. How about now when x is positive and y is negative over the same point? So if x is positive root 2 over 2, y is negative 1 over 2, it follows that when I substitute these two values into this equation to find lambda, the value will be the same. What will be different is the sign. So it means now the value of lambda will be given by negative 2. And then this can be generalized as lambda to be equals to plus or minus root 2. Then out of this, now we have found the values of x, y, and lambda. We want to know that our points are maximum or minimum. Let us look at the following. We have the point x. When x is positive root 2 over 2, y can be positive half. This is our first point. Then our second point, when x is positive root 2 over 2, y can be negative half, negative 1 over 2. Then this is our second point. The third point, when x is negative, this is x. When x is negative root 2 over 2, y can be positive half. And then the last point that we have is when x is negative root 2 over 2, when it's negative, y can also be negative 1 over 2. So now we have the following points. All we have to do is to check whether this point is subject to the constraint. It means now we have to take each point and substitute into the constraint, and if we get the value of y, it means that point we are going to use it as either maximum or minimum when we go further in this problem. If it happens that a point doesn't give us the value of the constraint, then that point we have to eliminate it. And then for now, let me look at the following. I will start by writing the points first. We have the points of root 2 over 2, 1 over 2, and then root 2 over 2 negative half. We also have the negative root 2 over 2 positive half, and lastly negative root 2 over 2 and negative half. Then let us take this point and substitute into the constraint. Remember, our constraint is given by x squared plus 2y squared equal to 1. So this is x, this is y. Then if x is root 2 squared plus 2, y is half, 1 over 2 squared, we must get a 1. Then let's check the left hand side. Root 2 squared is nothing but 2 over 2 squared is a 4 plus 2 multiplied by 1 squared is a 1, 2 squared is a 4. This must be equal to 1. Then 2 over 2 is nothing but a half plus 2 over 4 is also a half. Then when we check, the left hand side is equal to the right hand side. It means this point subject to the constraint. We will need it. Take note of that. Now let's look at the second point. The second point is positive and negative. However, we have the squares. So since we have the squares, then whether a point will be positive or negative, it won't matter. What matters is the final answer that we are going to get on the right. So we can clearly see that from here, now let us have these points. This one, root 2 over 2 squared plus 2 minus half squared. This must be equal 1. Then from this we can clearly see that this is just the same as 1 over 2 plus this is also 1 over 2. Then the left hand side is equal to the right hand side. Then from this we can predict that all these 4 points, they subject to the constraint. And then we want to know which of these points are maximum or minimum. And then let's look at the first point. We substitute the first point into the function x and y. This is the function. Then when we substitute this point, root 2 over 2 half, the value of x is root 2 over 2 and the value of y is positive. Then we can see that this is 4 multiplied by root 2 multiplied by 1 is just root 2. 2 times 2 is a 4. Then 4 will cancel 4 and we have root 2 as positive. Then let us find another point. The second one is this one. So this is f of root 2 over 2 minus half. Then we substitute into the equation. When we substitute into the equation, we can see that the numbers are the same. Since they multiply each other, it means the answer will be the same. However, the sign will differ. It means now here we are going to get negative root 2. Then also here is just the change of sign, and this one is not the change of sign. So everything on this one will be positive. Then if it's positive, it means the negative will multiply the negative, and finally we'll get a positive answer. So it means when f is negative root 2 over 2 and a positive half, we get a negative root 2. Then when x is negative root 2 and 2 and negative half, we get positive root 2. Then we check here, this one is positive, this one is positive, then these two are negative. Since this one is greater than the negative, it means the point root 2 and 2, root 2 over 2 and 1 over 2, and this one, the two are positive, minus root 2 over 2 minus 1 over 2. These points are maximum. Then this one with negative, because they are less than this point, they give us a minimum point. Then root 2 over 2 minus 1 over 2, and the point minus, which one is this? Okay, minus root 2 over 2 and 1 over 2. This point is a minimum. And then we can also look at the following example for the sake of practice. Let me say we are given x squared y plus 2y, and the constraint is x squared plus y squared equal to 1. We want to find the maximum and the minimum values. So first we have said that we have to identify the first equation as our function f. Then this is x squared y plus 2y, and then the constraint, and then you can call it g or any function. So I will call it g. This is x squared plus y squared. I take positive 1 from the right to the left, it becomes negative, so it becomes negative 1. And then we've said that we have to form a system of equations with 3 variables. So now we have x, y, and the third variable is a lambda. This might be equal to this equation, the equation of f. So this is x squared y plus 2y. We subtract lambda, we multiply the constraint, and then this is our constraint. This is x squared plus y squared minus 1, like that. So from now on, we have the first equation, f sub x is equal to lambda multiplied by g sub x. We'll use this equation. Then we'll also need f sub y equals to lambda g sub y. F sub x, we differentiate the function f with respect to x. This is our function f. Then we'll have 2x y plus, so this one 2y is a constant because it doesn't contain the variable x. Then it will give us a 0. Then lambda g sub x, we differentiate the constraint with respect to x, we'll get 2x. And then we can see that 2x will cancel 2x. Then on the left we'll have y equals to lambda, like this. Then this is our equation 1. Then we can now find f sub y or lambda from this equation. F sub y is the function f, we differentiate it with respect to y. Then this is nothing but x squared plus, because we differentiate with respect to y, plus 2 is equal to lambda. Then we differentiate the constraint with respect to y. So this one is a 0, and then this one will give us 2y. And then now we will have x squared plus 2 equals to 2y lambda. So out of this we can make lambda the subject of the formula in this equation. Then if we decide to make lambda the subject of the formula, we get x squared plus 2. This is divided by 2y. This is equation 2. And then now we can equate the two equations, because now the two lambdas are equal. Equation 1 is equal to equation 2. So on the left we'll have y, then on the right we have x squared plus 2, all this is divided by 2y. Then we can now cross multiply. When we cross multiply, we get the following. Then on the left we'll get 2y squared is equals to x squared plus 2, x squared plus 2, like this. Then we have to proceed with this equation so that we can relate one of the terms with the constraint. Let us now make x squared the subject of the formula. If we make x squared the subject of the formula, we'll have 2y squared minus 2. So now this information can be related with what we have into the constraint. Then it means we are going to replace the value of x with what we have here in the constraint. Then we've said that x squared, this is x squared equals to 2y squared minus 2. Now where there is x squared, I plug in 2y squared minus 2. 2y squared minus 2 plus y squared is nothing but equal to a 1. So now we can see we have 2y squared plus y squared. Then this will give me 3y squared minus 2. I will take it to the left, to the right. So I will have 1 plus 2, and 1 plus 2 is 3. Then we see that 1 plus 2 we get 3 like this. So we can divide by 3. When we divide by 3, we get y squared equals to a 1. So we take the square root both sides. It means y is equal to plus or minus 1. Now we find the values of y. We can try to look for an equation that will help us find the values of x and lambda. When we check equation 1, we've said that y is equal to lambda directly from equation 1. It means this equation can help us find the values of lambda. So since y equals to plus and minus 1 and y equals to lambda, it means also lambda must be equal to plus or minus 1. Now we have the value of x, the value of y and the value of lambda. So let us now try to find the values of x. Which equation can we use to find the values of x? We can use the same equation, the constraint, and finding the values of x. So if we want to make x the subject of the formula, x squared plus, then now if y is equal to positive 1, so if y is positive 1, then where there is y, I'm going to plug in 1. 1 squared is a 1. This is equal to a 1. So x squared is equal to 1 minus 1 is a 0. Then it means now the values of x is nothing but a 0 like this. So if y is positive, x is a 0. Then let me say now if y is negative 1, because y must be plus or minus 1. So if y is negative 1, then I have to find the value of x. It means x squared plus, where there is y, I put in negative 1 equals to 1. Then x squared, this is nothing but a 1. When I take it to the right, it becomes negative. So I will have 1 minus 1, and 1 minus 1 is a 0. So x is also equals to 0. Now I can take the following point. So when x is a 0, y can be positive 1. And again, when x is a 0, y can be negative 1. So these are the 2 points that we have for this equation. And then now we want to determine whether this point a maximum or a minimum. Then I'm going to substitute this point into the original function of f of x, this one. And then f of x, when x is a 0, y is a 1, then I will have x. I've said that x is a 0, so this is a 0 multiplied by y. Y is a minus 1 plus 2. Y is minus 1. And then this is a 0. 2 multiplied by minus 1, I get minus 2. So it's negative 2. And then let me also substitute using this point when x is a 0 and y is a minus 1. So this is the equation. X is a 0. It means I'll have 0 plus 2. And then y is minus 1. Actually, the first one, x and y is supposed to be positive. This is positive. So it means the value of f L0 and y is positive. Then this one will give me a negative 2. So we can clearly see that this point gives us a positive answer and this point gives us a negative answer. It means 0 and 1 is a maximum and the 0 and minus 1 is a minimum point. So that's it for this video. I hope you enjoyed. So you can subscribe to this channel so that every time when I post new videos you can also have access to them. Thank you.